La 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 la, Elmo swear. Alright, for today, we are going to show you how we use biostatistics to answer a research question. So as you can see, the research question is the mean heart rate of obese adults higher than the mean heart rate of underweight adults? So from this question, we can see that the independent variable is the weight status and the dependent variable is the heart rate. Why and how obese adults may have higher heart rates? So in their diet, if they are taking in excess calories, excess trans fat or saturated fat, it causes the blood cholesterol to rise. From this picture, you can see that being overweight can lead to high blood pressure and other related complications. Being overweight can cause the blood vessel to be damaged. So we conclude that this may cause the heart rate of overweight adults to be higher than underweight adults. From this set of data, you can see that the average heart rate for obese adults is 82.02, standard deviation 8.46, median 81.5, range 42, lower quartile range 7.75, mode 80, and the graph is slightly skewed towards the left by minus 0.14 with a 0.7 kurtosis. So now, by comparing the heart rates of the underweight adults, we can see that the mean of the underweight adults is lower compared to the overweight adults. The mean is 77.66, which is about 5 units lower compared to the overweight adults. We also can see that the graph is skewed towards the right, hence it shows that the average median mode of the heart rates are lower compared to the overweight adults. This is a summarized data of the heart rates between underweight adults and obese adults shown in a box plot. Moving on to the inference statistics. And since we are not given the variances for the data, we have to find out whether the variances are equal or unequal. So we have to do variance. We have formed two hypotheses. The first one, we assume that the variances are equal. And the second one, we suspect that the variances are not equal. By using Minitab as well as the F-test method, we have found out that the test statistics is 0.42 and the p-value is 0.003. And by comparing the p-value and alpha, since p-value is lesser than alpha, we reject H now. Therefore, the variances are not equal. Finally, we have reached our actual hypothesis testing on the means. So for the null hypothesis, we will be using the heart rate of obese adult to be more than the heart rate of the underweight adults. And for our hypothesis that we are testing, we will be using the heart rate of obese adults to be lesser than the heart rate of underweight adults. So by using a left-tailed t-test and a level of significance of 5%, we found out that the TS, which is the test statistic, turns out to be 1.98, p-value to be 97.4%. Hence, since p-value is more than alpha, we will not reject H now. Therefore, the test is insignificant. Next, we have the confidence interval. So how do we find it? Firstly, we use the standard error, which is 2.2053, and the margin of error, which is the t-value times the standard error, which is 4.366. So by using the formula of the confidence interval, we found out that the mean heart rate of the obese adults minus the mean heart rate of the underweight adults should be lesser or equal to 8.73. For power of test, we have taken 50 sample size per group and standard deviation of 11.105 as well as margin of error of 4.366, and using the Minitab we have computed a power of 62.7%. So as seen from the Minitab, In order to get a 90% power, we have to increase our sample size to 110 per group. Ta-da! Lastly, for our acceptance and rejection, we have drew out the left tilt test graph, and as we can see from the graph, our TS, which is the T value, is 1.98. So we accept H now when T value is more than 1.664, reject H0 when T value is less than negative 1.664, which is the T creep. So we can see the T value is more than T creep. Therefore, H now is not rejected. Hence, the test is insignificant. From hypothesis testing, our belief that the mean heart rate of obese adults is higher than that of underweight adults is correct. The result matches our initial research, which shows that obese adults do tend to have higher heart rates. This makes our conclusion from the hypothesis testing a valid one. If we had the opportunity to request for data again, we would still stick with the sample of 50 for each group of people. This is because we believe that taking a sample of 50 is representative enough of a population of obese and underweight people. I love you, you love me, we are a happy family with a great big hug and kiss from me to you. Won't you say you love me too?